Today's homework involves the two different lessons that we learned today. The first one is simplifying radicals, and the second one is approximating radicals. Now, if we actually simplify the radicals first, you're going to see that it's a lot easier for you to actually approximate because your radical is much smaller than the original. So for example, if I do radical 18, I'm going to go ahead and do the factor tree that we learned today in class. So I'm going to start with 18, and I'm going to figure out the two factors. So I'm going to go with 6 times 3. You can go with 2 times 9. It doesn't matter as long as it's not 1 times 18. I notice that 3 is a prime, so I'm going to circle that. And then I have 2 times 3. Those are also primes. That means I can't break it down any further unless I use 1, and I don't want to use 1. So now I have 2 3's and a 2. Essentially, this means it's 3 times 3 times 2, which equals 18. But to simplify it, I notice that 3 times 3 gives me a perfect square of 9, so square root of 9 gives me 3, and the radical 2 will remain on the inside. So now they want me to approximate to the nearest tenth. I'm going to go ahead and just take the radical 2. Radical 2 is between two perfect squares of radical 1 and radical 4. So the two whole numbers this is going to be between is 1 and 2. So radical 2 is between 1 and 2, so it's probably 1 point some kind of decimal. Now we have to keep in mind that we also have this 3, which means 3 times radical 2. Okay, so we can't forget that 3. As we move on, I'm going to make myself a little number line of square root of 1, square root of 2, square root of 3, and square root of 4. I need to count the spaces that are in total from square root of 1 to square root of 4. So the spaces are 1, 2, 3. So my total is going to be out of 3. Out of the 3, how many spaces does it take for me to get to radical 2? So from here to here takes me 1 space. So now I have 1/3, which is approximately 0 point repeating 3. We also said that radical 2 is between 1 and 2. So it's going to be 1 point repeating 3. This is equivalent to this. Now I take this and multiply by 3. So 1 point repeating 3 times 3 gives me approximately 3.9. And since they want me to round to the nearest tenth, I'm good right here. So I'm going to round it to 3.9. We'll try a few more together, and then I'll leave you with some to do on your own. So approximating radical 30. I'm going to go ahead and simplify that big number first, just so that I can make it easier on myself. So I have radical 30. I'm going to take 30 and break it down into a factor tree. I'm going to go with 10 times 3. With 10, I have 2 and 5, and those are my primes as well. So if I take a look inside the radical after it has primes, I have no perfect squares, no pairs. That means that radical 30 is as simplified as it could possibly be. So I'm going to have to use radical 30. Between the two for radical 30, I have radical 25 and radical 36. So it's between 5 and 6. So it's going to be 5 point something. I'm going to go ahead and list my numbers. I don't necessarily have to if I just subtract. For example, when we go back to number 1, 4 minus 3, 4 minus 1 gave me the 3. 2 minus 1 gave me the 1. So if you feel like writing the timeline is, or the number line is a little bit too redundant for you, you can always do that as well. So I'm going to go ahead and do that. 36 minus 25 gives me a total of 11. And then to get from 30 to 25 takes me 5 spaces. So remember, this is a 1 unit. You cannot use a calculator, even if it is for a simple division as 5 and 11. So we're going to have to divide 5 divided by 11. Put down that decimal. So I end up with 4 to get 44. And then 6 and 0. Now we're approximating to the nearest tenth, so I'm okay with using 0.45. So 0.45 is this decimal here plus this 5, because it has to be between 5 and 6. So I end up with 5.5 because they want it to the nearest tenth, and I use the 5 to round the 4 up. So this is now my number. Okay, I'm going to do 2 more with you, and then the other 4 you're going to do on your own. So 5, I can tell that I cannot break it any further except for 1 and 5. So I'm going to go ahead and put 5 in between. So I have radical 1 and radical, radical 4, I apologize, and then radical 9. So it's between 2 and 3. So your answer is going to be 2 point some number. Once again, my total is going to be 9 minus the 4. That's 5. And 5 minus the 4. That's 1. So 1 divided by 5 gives me 0.2. So 2.2 would be my answer. Okay. For 12, I'm going to go ahead and simplify first. I have 3 times 4, that's a prime. And then I have 2 times 2, more primes. So eventually I get 2 times 2 times 3. 2 times 2 gives me 4, so that's a perfect square of 2. And then I have to multiply by radical 3. So I'm going to estimate the radical 3 first. Radical 3 is between radical 1 and radical 4. So it's between 1 and 2. So 1 point some number. Then we're going to not forget the 2 to multiply. So from there we have 3 spaces by 4 minus 1. And then 3 minus 1 to give you 2. So I get approximately 0.6 repeating. However, it's between 1 and 2, so it's going to be 1 point repeating 6. And then I have to double that by multiplying by 2. So I'm going to go ahead and multiply by 2, and I end up with 3.2 as my answer. Now, you may punch in these radicals in your calculators to check, but since it's an approximation, sometimes it's very off. For example, number 1, if you punch it into a calculator, it's about 4.24 instead of the 3.9. But the SBAC will take the 3.9 because this is one method of actually approximating your radicals. I'm going to go ahead and start number 5 for you by simplifying it, and then you're going to find the approximation to the nearest tenth. So 20 can be broken down to 4 times 5, and then 2 times 2. Here's a prime, and a prime. So I end up with 2 times 2 times 5. So I can actually take out the 2. So I have 2 radical 5. Now this one seems a little bit more simpler because radical 5, guess what? I already have that decimal here. So you're going to take 2.2 times 2 and figure out what your answer is going to be. Radical 3, we already did it right here. The only difference is we don't have to multiply the 2, we're just looking for 3. Number 7, we have 58. Now anytime it ends with an even number, you can divide by 2, even if you don't know what your numbers are. So 2 times 29 is going to be my factors. And if I look at 29, I can't break that down anymore. So radical 58 is actually already simplified, and it's important that you know that. So I'm going to help you out by finding the 2 perfect squares it goes between. So what comes to mind is 64. That's 8 times 8, so this one must be 7 times 7 to get 49. Go ahead and find your total, and then how many between these two to find your numerator, and then divide that. And then 8, we can factor that as well. We get 4 times 2, so we get 2 times 2 here, and we end up with 3 2's. Since we're not doing cube root, the answer is not 2. The answer in this case is still 2 radical 2. And since we already did radical 2 in number 1, you can go ahead and solve the same thing using 1.3, and instead of multiplying by 3, you would be multiplying by 2 to get your final answer.